Good afternoon. Welcome to today's 8th session. Myself Ms.BHARATHI, Associate Professor of EEE Department, SA Engineering College. Today we are going to talk about transient analysis, which is a very important topic in our GATE syllabus, EEE Department. Transient analysis we will discuss in circuit theory, which is a very important concept in circuit theory, transient analysis. In that circuit theory we have discussed about RL transients, RC transients, RLC transients, DC, and for AC inputs and DC inputs we have discussed transient analysis. Today we are going to talk about transient analysis, some concepts behind the transient analysis and the problem related with the transient analysis. GATE problem will be discussed today. So transient analysis, what does mean by transient? Transient means which is nothing but a short lived, which live only for a shorter duration. That is nothing but a transient. In case of circuits, electrical circuits, when the input is given for the R, L, C components connected with that, for example, suppose for example, if we have R, L, C, like that we have the circuit and some voltage is given to the circuit, we know some current will get. This current will not be obtained instantaneously. It will take some time to reach that particular value of current. So before reaching the steady state current, after certain period of time, what will happen? What will be the current in the circuit before reaching the steady state? So before applying the voltage, it is said to be the steady state. No voltage is applied. That is the steady state condition for the RLC circuit, for example. And if you apply the voltage, then for this RLC circuit, the current will be passing through this, but the steady state current will be passing only after a certain period of time. There will be the time taken for reaching the steady state current, like this. Now this will be your steady state current. So before reaching the steady state current value, this period from 0 to before reaching the steady state value, we have certain period of time. That time period is said to be the transient time period, and the voltage or the current value what we are obtaining during the transient time period is nothing but transient voltage or transient current. So like that, this is the basic concept behind the transient analysis. So we are going to talk about transient analysis for our RL circuit. Today in today's class we are going to talk about transient analysis for RL circuit and problem related with that. So first, transient is nothing but before reaching the steady state, what will be the voltage and what will be the current in that particular circuit. That is nothing but transient current. We'll move to next slide. So here we have the forced response and natural response. Forced response means from the name itself we can understand some input voltage is given to the circuit and we are going for obtaining the response of the circuit, but we are assuming all the initial conditions are zero. All the initial conditions, what is meant by initial conditions? In this case we are going for using the storage elements, resistive element, inductive element and capacitive element. Resistance will not store any energy, we know that, but capacitance and inductor will store the energy. So the energy stored by the inductor and energy stored by the capacitor will lead to some voltage or current in it. So what about the current passing through the inductor? What about the current passing through the capacitor before switching? That is nothing but the initial conditions of the circuit. So assuming all the initial conditions are zero and if the input voltage, external input voltage is given to the circuit, that is said to be the forced response. And natural response is nothing but there is no input given, external input will be given, but we will assume all the initial conditions of the circuit. For example, current through the inductor will be considered and voltage across the capacitor will be considered. So like that, initial conditions are included, but there is no input given. So that is nothing but a natural response. And the total response of the circuit is nothing but forced response plus natural response. Like that, we will go for considering a response of the particular circuit. And it is very important to know about the initial conditions of voltage, initial conditions of the capacitor and the inductor. What is the initial condition of the capacitor? So here we have to discuss about three conditions: T of 0 minus, T of 0, T of 0 plus. These three are very important. T of 0. Always the switch will be closed at time t is equal to 0. That means you are going for applying the voltage or you are going for removing the voltage. That will be done at time t is equal to 0. So this is at the time of switching. Then what is T of 0 minus? Before switching. Before giving the supply to the circuit or after giving, that is after removing the supply from the circuit, what will be the condition of your circuit? That is nothing but T of 0 minus. So this is nothing but before switching. And T of 0 plus is nothing but after switching after certain period of time. At time t equal to 0, switch will be closed, and after certain period of time, T of 0 plus, just after the switching, that condition is said to be T of 0 plus. And one more condition is there, T of infinity, which is nothing but the steady state condition. Current will reach or voltage will reach its steady state value. That is nothing but T of infinity. At what time the current will reach the steady state value or the voltage will reach the steady state value. That is nothing but a T of infinity. So based on this, we have to discuss about VC at time t equal to 0. When the switch is closed, voltage across the capacitor before switching and after switching will be equal. This is the initial condition for the capacitor. That means voltage across the capacitor before switching will be equal to the voltage across the capacitor after switching. So we have to consider the voltage. If there is any present in the capacitor, we have to include that particular value of initial capacitance voltage to the response when we are calculating after switching also. That means initial condition of the capacitor is this value. And we are going for talking about the inductor. In case of inductor, we can consider the current. So the current passing through the inductor before switching will be equal to the current passing through the inductor after switching. So in this case, we have to surely consider the current passing through the inductor before switching to the response. That is very important. So initial condition of the inductor will be equal to IL of 0 minus will be equal to IL of 0 plus. If there is any current in the inductor, that should also be considered for the response after switching also. That is the meaning of initial conditions of initial conditions of voltage across the capacitor and initial conditions of current through the capacitor. So this is very important. And the second one is a very important note. At steady state condition, in case of T of infinity, the capacitor will be acting as an open circuit and the inductor will be acting as a short circuit. This is also the important thing. So these are the basic criteria when we are talking about analysis. We have to consider basic things. What about the initial conditions for the capacitor and the inductor? And the capacitor will be acting as an open circuit, inductor will be acting as a short circuit for the steady state condition. So this is about our RL series circuit. So this is a simple circuit which has R resistance in series with our inductor. So RL series circuit. Here we are going for applying the voltage. Now see, the switch is in open condition. So you can say the switch is in open condition now. At time t equal to 0, the switch is going to be closed. So the switch is closed at time t equal to 0. Now at this time R and L will be coming in series, and before reaching the steady state value, what is the response of the circuit? What about the current passing through the circuit? That we have to calculate. So that is nothing but the current passing through your RL circuit, nothing but transient current. The response of the circuit will be like this only. Mathematical terms that we will discuss in the formula problem. So here response of the circuit is, here we can say this is the time period, and here we can say this will be the transient current or the current axis. We know that before reaching the steady state value, from 0 to before reaching the steady state value, we have the certain exponential increment of the current value. So you can say the current is increasing exponentially and it reaches steady state value after a certain period of time. So at time t equal to 0, current starts rising when the switch is closed. You are applying the voltage, switch is closed, so you have applied the voltage to the circuit. So the current starts increasing, the current increasing in the exponential way. So this period before reaching the steady state value, from 0 to before reaching the steady state value, this period is nothing but the transient period, and the current passing through this circuit during the transient period is nothing but the transient response. So like that you can calculate, or you can go for analyzing about your transient current during the transient period, and here this will be the steady state condition, current reaches the steady state value. So this is the response of our RL circuit. Now we can go for the formula. I think this is enough about the basic concepts behind the transients and RL transient. Now we can go for discussing about the gate problem, which is very important problem which was there in previous year gate question papers. So this is the problem I have taken for discussing in today's session. This problem is circuit diagram is given. Here we have R and L circuit, and by seeing the switch and arrow mark itself, we can understand this is the problem related with the transient. If you have the switch and some arrow mark condition at time t equal to 0, you can analyze. This is your transient analysis problem. Now in this problem, the switch S is in the closed position for a very long period of time. So where is our switch? So you can say the switch is our switch is here. So the switch S is in the circuit. The switch is in closed position for a longer period of time. If the switch is opened at time t equal to 0, then what is IL of t in amperes? So what they are asking in the problem, already switch was in closed condition. If the switch is opened, what will be the current passing through the inductor? So this is your IL of t, nothing but current passing through the inductor after the switch is opened. That is what the problem. So they have given some choices, A, B, C, D, some 4 choices are given. So we have to go for analyzing this problem, and then we can go for concluding what will be the result for this. So understand the problem first. Switch was in closed condition, and the circuit will have the current, and all those initial current, everything will be passing through the inductor. All those things will happen in the circuit. It is in steady state condition now. Now you are going for opening the switch. When the switch is opened, what will be the current passing through the inductor? That we have to calculate. So we can continue with the problem. So here there are different 3 conditions we have to discuss. What about the current passing through the inductor before switching? It means that at time t is lesser than 0 and t is greater than 0 and t is at infinity. So t is lesser than 0 means switch will be opened at time t equal to 0. Switch will be opened at time t equal to 0. So before lesser than t means before switching, that is when the switch was in closed position. That is the first condition what we have to calculate. And the second condition is nothing but just after switching. IL of 0 plus what will be there, and IL of infinity. That is in the steady state condition what will be the current passing through the inductor, that we have to discuss. So there will be the 3 different conditions. So first condition is nothing but for time is lesser than 0. Now the switch was is in closed condition. You are not doing anything. Switch was is in closed condition only. So at time t is lesser than 0. Now here if you see the circuit, when the switch was is in closed condition, see here. So here when the switch was is in closed condition, here when the switch is in closed condition, we can say the current will take the path only through this path. Current will take only through this path, and this 4 ohm and 30 volt will be neglected at the time. We know that always the current will prefer the short circuited path. So here you can say the current passing through the circuit will take only the short circuited path. That means this closed path and 1 ohm resistor, inductor, like that. The current will not flow through this 4 ohm and 30 volt. This is the property of the current which will take the least resistance path. So you can say IL of 0 minus, that is when the time is lesser than 0, current will be IL of 0 minus, that value will be only this 10 volts and this divided by 1 ohm resistor. So 10 volt divided by 1 ohm resistor will give you the current, that is nothing but a 10 ampere. So here you can say IL of 0 plus will be equal to, so here you can say it is your IL of 0 minus, this is actually So IL of 0 plus will be equal to IL of 0 minus is equal to 10 ampere. Already we know that the initial condition for the inductor is IL of 0 minus will be equal to IL of 0 plus. That is, the current passing through the inductor before switching will be equal to after switching. So you can say IL of 0 plus will also be equal to 10 ampere. So just let us keep this value. IL of 0 plus will be equal to 10 ampere. And second condition is, this is before switching was happening and after switching. Now the switching means here the switch will be opened. The closed switch will be opened. This S switch will be opened. That is nothing but the switching. Switching means it may be closing or opening. Both are said to be switching only. In this case, the switch is going to be opened. That condition is said to be the switching. So after the switch is opened, here the time period will be greater than 0 because switching will be done at time t equal to 0. So we are going for discussing what will happen after the switch is going to be opened. So now it is in open condition. Now you can say this is the circuit diagram for us. Here we have the 10 volt source, 4 ampere, 4 ohms will be the resistance, 30 volt is connected with this, and this will be our 1 ohm resistor, and here we have the inductive part. Now in this case, current will not flow through the open circuited path. Our current will be passing through like this. Now we can go for discussing about the third condition. This is the circuit diagram for this. Now we can go for discussing about the third condition, which is nothing but time transient, that is time period, which is infinity, when time is equal to infinity. So now we are going for discussing about the third condition, which is nothing but t is equal to infinity, which is the steady state condition for that circuit. So already we know our circuit, I of infinity will be equal to, so in our previous circuit, if you see, here we have 10 volt and 30 volt. 10 and 30 are connected in series, so 10 and 30 will be added, 40 divided by, here we have 4 ohm and 1 ohm connected in series, so we can say it is our 5 ohms. So 40 by 5 will give you 8 amperes. So 8 ampere will be the current passing through the inductor at infinite condition. That means at the steady state condition. Current passing through the inductor at the infinite condition is said to be 8 amperes. So here we have the two values of current, which is current passing through the inductor just after switching, IL of 0 plus, which is 10 ampere, and before, that is at infinite condition, that means at the steady state condition, which is IL of infinity 8 amperes. Now we can go for talking about what is the current passing through the inductor at time t, at any time t. IL of t, nothing but the transient current. So this transient current can be obtained by using the charging equation. The charging equation is nothing but the charging equation for the first order RL circuit, which is given by IL of t, which is equal to I of infinity plus I of infinity minus IL of 0 plus multiplied by e power minus r by L into t, minus I of infinity, IL of 0 plus is 10 and I of infinity is nothing but 8, e power minus r by L, r value is nothing but 5 and L value is nothing but 0.5 into t. So here we can get the value 8 plus 10 minus 8 will be 2, e power minus 5 by 5 is nothing but 10, so e power minus 10t. So the answer which is nothing but the current passing through the inductor is given by 8 plus 2 e power minus 10 into t. Now we can go for verifying with our answers. You can see here we have the answer 8 plus 2 e power minus 10 into t. So students, this will be the answer for this particular problem. Now I thank you all for watching this session, and we will meet in some other YouTube video regarding transient analysis of RC circuit and problem related with that. Thank you all.